in general, the size of the input. Now n might be the degree of polynomial, any degree of a polynomial equation, or size of a file, or number of characters in a string. So these can be the inputs. This can be the input to the algorithm. For example, if your algorithm you want to do some operation with the text in your algorithm. Now this text has the size of the text or the length of the text, okay, is the input to the program or to the algorithm. Now algorithm will process this text, will read the characters character by character, or remove the character, do whatever the operation. So what is your input is n, which is the size of the string or the text, or it can be size of the file. You want to process some file in your program or in your algorithm, so it will take the size of the file. What is the size of the file? Then based on that, it will go inside the file and look for the contents and do whatever the operations. Some other abstract measures of the size of problem being considered. It is, for example, size of the array. For example, you have an array, the size of the array, or size of linked list, or size of the two-dimensional array, whatever it is. Okay. So here, what is the important thing is we are going to check the time complexity based on the size of the input, which is n. Which is n. Now, based on this n, we are going to perform all the complexities. From here, from the next line, we are going to check the time complexity for the algorithm by taking n. N is the size of the input given to the algorithm. Okay. Almost all algorithms run longer on longer inputs. As the input grows, the algorithm takes more time. For example, sorting an array. If you have two elements, for example, 10, 9, to sort this, it will just take one step. And bring this element over here, it is sorted. Now, if it is size 2, size of your array is 2. If you have size 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, then you need to have 10 moves. So it will take more time compared to this. That's what it means. An algorithm run longer on longer inputs. If the input is high, it will take more and more time. Okay. Finding the largest element in an array. Again the same thing. For example, if there are 10 elements, if the element is found in, yeah, it can be found in any place. It can be found in the first place, or it can be found in the last, or it can be found in the middle, or it cannot be found. No, sorry, the largest, there should be an element, so it can be found any place. So as the array grows, the size of the array grows, the time will also grow, or it will take more time. Solving the traveling salesman problem. You know about this problem? Traveling salesman problem? No. Traveling salesman problem is, there is a salesman who wants to go from one place to another place. One place to another place. For example, this is place A, this is place B. There is a salesman who wants to travel from A to B, and there are different routes. Or like this. Sorry. There are different routes for him. So in this problem, you have to find which is the nearest or the best way for him, or from A to B, okay, which is the best one will take short time to travel from A to B. This is called travel salesman problem. Even in the traveling salesman problem, if your input is more, Input is nothing but your paths. For example, this 1, 2, 3, 4 different paths, then the algorithm will take more time because it has to calculate every path which is the shortest distance. Okay. So these are some examples of for this statement that an algorithm run longer on longer inputs. Okay. The running time of an iterative algorithm depend on number of repetitions of the body of the loop. If the algorithm has a loop, or for example, let's take as a for loop. So if there is a loop, so it also depends on how many times the loop is executed, because it will take every time, it will take some time for that. So we'll also consider that if there is a loop, how many times the loop is executed. Sometimes the running time not only affected by the input size but also by the input itself. Not just the size of the input, but the input itself. For example, you want to searching a key in a list of array called A. Searching an element in a array. For example, let us take, for example, there is an array A. It has 8, 7, 5, 6, 4. This is the size of the input is 1, 2, 3, 4, 5. 5. The array of size 5. Sometimes, for example, you want to search an element k, let's say k is equal to 7. Now, in this case, in the searching problem, what happens here, the algorithm is executed till the 7 is found. After that, it will not execute. So, your time is consumed till here. Okay. Now, at this point, the running time of the algorithm is based on the value of this input, not on the size of the input. Clear? It's not clear. Okay, these problems, the time, it depends on the size of the input. Sorting an array, if there are 10 elements, size is 10, size of the input is 10, it will take more time. If there are 100 elements, it will take again more time. So as the input grows, the size of the input grows, the time is also, it will take more time, longer time. But sometimes it does not depend on the size itself, but it depends on the input itself. For example, this problem, searching an element. Now here the size is 5. You want to search for 7. 7 is found at the second place. After that, you no need to search. No need to go for three more elements. So you stop here. So your time is less than the size. Right? For example, let's say k is equal to 8. Now at this point, it will just found at the first place first. For example, k is equal to 4. Now it has to process all the array. The whole array it has to be. For example, let's say k is equal to 10. It has to process all the array and finally element not found. So that's what it says. Sometimes running time not only affected by the input size but also the input itself. So this input is affecting the running time of the algorithm. Yeah. Now here we'll analyze this, what this analyze about this statement. Okay. Now here let's take this one. Which of the following array? This is the code which has an while loop while I less than n and a of I not equal to k, I is equal to I plus n. If I is less than n, return I, else return minus 1. Now here what is happening? Which of the following array will take long running time in case of searching the key, that is 6? The first input is in the first input 6 is found and the last before the last, and the second 6 is found in the second position. Which will take longer time? Definitely A1 will take longer time. Now here the time of the algorithm dependent on the value of k, the value of input itself dependent on k. It depends on, for example, let's say k is equal to now 10. There is no element. It will take whole time to process the complete array and the element not found. Okay, so it depends on value of the input itself. Okay, now here we can divide this, in this case we can divide the analysis into three cases: best case, average case, and the worst case. Best case is when the element found at the first position, it is the best. And the element found, if the element found in the last position or element not found, it is the worst case. And if the element found somewhere in the middle, then it is an average case. So we divide, based on this algorithm, we divide the time complexity into three cases: best, average, and worst. Okay, so here for example, if you consider the A1 is the worst case, we can consider this as a worst case because the element found in the last place or before the last. This can be considered as the best case. Okay, and if the element is found somewhere in between or in the middle, then it is an average case. Now usually when you try to estimate the time complexity or the running time of algorithm, we always estimate the worst case because we don't know whether it will go, whether the element will found or not found. Okay, so we'll give the worst time, the worst case time. For example, let's say the best case will take 1 second, the worst case will take 10 seconds. The average will take 5 seconds. We say that, okay, the time complexity for this algorithm is 10 seconds. We give the worst one because if there is no element found, so it will take 10 seconds. If it is the element found, okay, it will take, might be the best case or the average or the worst case. So to be more clear, we say the worst case. We don't say the best case because if you say best case, we say that this algorithm will take only 1 second, which is the best case, and element is not found at the first position, then you are wrong, your time complexity is wrong. So that's why we say no, give the worst case, give them, give the time complexity which is the worst case, which will process all the elements. Okay, clear? Now suppose that we have two methods A and B. The method A is 10n square minus 5 and the method B is 100n plus 200 milliseconds to process n elements. Size of the input is n. Okay, this is the method or this is the function, you can say. Okay, now here we are comparing these two methods. Or for example, let us consider these two methods A and B is a solution to some problem. There is a problem P1. The solution is method A and method B. Now you have to check the time complexity. The size of the input is n. Now we'll check the complexity for the input n based on this graph. Now if you say for the A, this one is A, method A, and this is method B. Okay, for a small value of n, for a small value of n, the A will take less time compared to B. From this graph, this is the time, this is the running time, and this is the value of n. For a small value of A, for example, value of A 1, 2, 3, 4, 5, 6, 7, 8, for these values, A will take less time compared to B. But whether it is true for the big values when the n become large. Okay. Now when the n become large, A will take more time and B will take less time. Because when you start from this point, for example 12, okay, the method A is 10n square minus 5, method B is 100n plus 200. So let us take for example 12, 10 into 12 square minus 5. Okay, so how much it is? 10 into 12 square? Minus 5. 1435. And how about 100 into 12 plus 200? 1400. Now it is coming very near. Now it is coming very near. Now if you take more, go ahead, move ahead. For example, let's say 10 into 15 square minus 5. And 10 into 15, sorry, 100 into 15 plus 200. And 1500 plus 200, 1700. Now which is taking more? A is taking more. So here for you can see the larger values of n for method B will take less time than A. So now it is the difference for small value of n are relatively insignificant, and what really concerns us is the asymptotic behavior of the running time function. So what happens when the n becomes larger? It will take large values. So to keep our running time expression general, we allow them to contain unspecified constant, and for example instead of taking these values, constant values, we keep it as A, B, C, D, which is unspecified, can take any value, okay, and these are depend on the factors such that speed of hardware or speed of the computer, okay. So here our concern is n square and n. So n square will take more time and n will take less time. Now here there is something called big O notation. Big O, we write it as like this, O, big O. The most commonly used notation for estimating the rate of function growth is the big O notation. How the function grows in terms of time. How the time grows for any function we estimate by using a big O notation. So the running time of algorithm A of the order n, a O of n. So here the running time for it is considered as n. Okay, we saw that it is big O of n, and for this big O of n square. This is what you need to understand. This is how the time complexity comes. What is the running time for A, running time for B? It depends the value of n on the n. As the n value grows, the time will be more and more. So we'll take here with the maximum one is big O of n square and the less one is big O of n. So the algorithm A takes the proportional to n square. We saw that its time is big complexity of big O of n square. No, it is algorithm B, not A. If algorithm B takes proportional to n square, we would say that its time complexity is big O of n square. Okay. So multiplying or dividing function by a positive constant does not change its order. Multiplying or dividing by any constant does not change the time of the n square. It remains as big O of n square. See, you, because of your phone call, you missed the main part. I'll repeat from here. If you see this one, for these two methods, I'm just repeating, okay? But you be careful that you should not use these things. Now, when the if you see these two methods, we are comparing these two methods, A and B, for to process n elements. So when there is a value of n is small, this is the value of n, and this is time. When there is a less n value, A will take less time. So it is taking only this much of time, but B is taking more and more time. But the n values, as the n values grows, B will take A will take more time compared to B. For example, let's say if n value is 15, then A will take 2245 and B will take 1700. So for the larger value of n, B will take less compared to A. Okay. Now we need to keep this as general. We need to keep this as general in terms of n. Okay. So how we represent that is by using a big O notation. Big O notation, we represent the complexity. The time complexity is represented by big O notation. So here our algorithm A will take the time complexity of big O of n, and algorithm B will take a big O of n square. Okay. Clear? Now here, even if you are multiplying by any constant or dividing by any constant, it remains same, big O of n square. If it is 2 power n, 2 power n, then 2 power n is more than n. So we'll take it big O of 2 power n. Okay. So a function order is not changed by adding or subtracting a function in a lower order. 2 power n is bigger than n and log n. So if you add n or log n, any other n which is less than 2 power n, any other n less than 2 power n, then which is the biggest one or the highest one is 2 power n. So we'll consider big O of 2 power n. We'll consider big O of 2 power n. So for example, let's say it is 2 power n plus 2n. Now for this we'll consider big O of 2 power n, because 2 power n is bigger compared to these factors. Okay. Now here these are the algorithm typically have running time proportional to one of the following functions. Function with a constant value 1, okay, all instructions are executed one or a few times. So it will take the running time as 1. Okay. Log n, it means logarithmic n. The program gets slightly slower as n grows. It means program will take time as the n keep on growing. Program gets slower. N, it means a linear function, a small amount of processing done on each input element. So it depends on the size of n. N log n, it is linear with algorithm. It's a combination of logarithmic and linear. It is a combination of this and this one. Both. N square is a quadratic equation. So all pairs of data perhaps in double nested loops. It means this n square comes in two loops, whereas n comes in one loop. If the algorithm has only one loop, then it will take n. If it has two loops, it will take n square. N cube is triple loop. It has three loops, then it will. 2 power n is exponential, where n doubles the running time squares. As the n grows, the running time will get the square of it. For example, n is 2, then the running time is 2 power 2. N is 4, running time is 2 power 4. N factorial is the algorithm generates all permutations of an element set. Factorial, it means multiplying to its lower till they reach the last element. Okay. Now these you need to remember, and these are going to be represented in the time complexity. Now here arrange the following expression from 1 to 5, where 1 represent the smallest and 5 represent the largest. Now here tell me which is the first one, the smallest one. Yeah. Number 2 is 2n power 4. Number 3 is the smallest one as it has just n. And the next is n log n. Number 3 is n cube. Number 4 n power 4. And number 5 is n power 4 log n. Yeah. So from this you can understand, which comes the lowest one, right? With just a n value is the lowest one. And before that, if there is no n at all, then that is the lowest one with just a constant value. Okay, but it will not come. It will come either with n or with n log n, n square, n cube, n power 4, 2 power n. Okay. Now here, determine the complexity of the following functions. Now what is the complexity for the first function? Big O of big O of n, because it has just n. The second one, n square, big O of n square. What is the complexity for the third one? N log n, 3, 3 power n, big O of 3 power n. What is the complexity for the constant? Only big O of 1, because the constant will take only 1. We saw the table over here, the constant will take only 1. What is the complexity for this? There is no n, it is just log n. Big O of log n. What is the complexity for this? N log n. Big O of n log n. Now what is the complexity for this? 2 power n. Big O of 2 power n. And what is, yeah, it is over here. And what is the complexity for this? N to the power of 5. And this one? Big O of 2 power n. Okay, addition of any constant, it does not matter. Addition, subtraction or division will not matter. Okay. big O of 1, big O of log n, big O of n log n to power n power 5, to power n. No. Time complexity for some Java codes. Now here we will consider the codes. Any statement will take the complexity 1 because it's a constant statement and which occurs only once. For example, x is equal to x plus 3 or int a is equal to 2. These are only executed only once. So those statement will take big O of 1. For any linear equation, for example, a linear loop, a for loop, for example, will take n because this loop, the worst case is executed n times. Okay. Now this one will take big O of n square. Why? Because there are two loops. The inner loops, slide 19, which is the slide 19? This one. Yeah. From the last. Yeah, 10, 100 n power 3 plus 2 power n. Because 2 power n will take the highest compared to n cube. Okay. For example, if you take, for example, let's take n is equal to 5. So 5 cube is 125, is it? 25 into 5, 125. Whereas if you take 2 power 5, 2 power 5 is, no, it will come around less than 100. Yeah, just 32. But as the n value grows, for example, if the n value grows. If you take n value, for example, let's say 100, and 100 2 power 100. Now, what is the value in that case? 2 to the power of, so this is the value for 2 to the power of 100. Okay, this is the value. And if you compare the value for, let's say, for example, n to the power of 100, so that is 100 cube. This is the value 100 cube. Now, which is the largest one? Yeah, the second one, the first one, 2 power n. So since the 2 power n is the largest one, so we'll consider 2 power n. Because I said at the beginning, while we are discussing, I said we'll consider the worst case. This is the largest one. Okay, so that's why we are considering here 2 power n, not n cube. Okay, clear? Okay, thank you very much. Yeah, if you come to here, okay. For any single statement which is executed only once, the complexity is constant, so it will take it is big O of 1. For a linear, it will take big O of n, that is with one for loop. For two for loops, you will take big O of n square. Okay. Then big O of log n, when this big O of log n is when the value of I has some changes. For example, over here in this for loop, the I is incremented only once, and we know that this loop is executed n times. So we considered as big of n. But whereas comes to over here, I is equal to I into 2, or j is greater than or equal to 1, j is equal to j divided by 2. There is the changes in the I or in j are not sequential. I mean sequential, I mean it is not one by one. The loop is jumping from a place to another place. The loop is jumping either by using a double value. As the I increments, it is multiplied by 2 and the loop keep on jumping. I1, then the first time it is it is 2, it will jump to the second. Then when I becomes 2, now it is jumping to the fourth. When I becomes 3, it is jumping to the sixth. So when there are changes with these kinds, then at this time we consider as logarithmic value. That is, we say as the time complexity is big O of log n. Big O of log n. Now here, in the second example, it is big O of n log n because the outer loop will definitely execute n times. The inner loop will have log n times. So here multiplying with these two, n log n. Okay, because the inner loop, the iteration has some changes in this. The value of j is not incremented by 1 or by decremented by 1, but there are some changes with respect to division or multiplication. So these are some, when we consider with the some Java code, time complexity for the Java codes. Okay, for any single statement big O of 1, for a single for loop with a sequential increments big O of n. For 2, if you have 2 for loops, big O of n square. If you have any changes in the I or in the j, it will take log n. Okay, either by multiplying or by division. Okay, or in this case, the outer loop execute n times, the inner loop execute log n times. So in this case, we say big of n log n. Okay. The counting step: to determine the order of the algorithm, we need to calculate the total running time following the steps below. Write the algorithm down in precise English or in any programming language such as Java. Determine how many steps are accomplished by each line and how many times the line is executed. How many steps are accomplished by each line? Each line of the code, how many uh, steps are accomplished and how many times the line is executed. So the time used by the line is the product of two expressions, the product of these two expressions. So the total running time of algorithm is the sum of time required for each line in order of this expression is same as the order of most time consuming lines. Example, let us analyze the sum function over here. The method sum that calculates the sum of elements in an array. The time in this method takes depend on the size of the array, which is supposed to be n. Okay, so here you see there is a one for loop. Okay, and we have some statements outside the for loop. This one and this one, three statement which is outside the for loop. Now we consider every statement which is executed only once with a constant, let's say time, it will take a time called c. This is also a single statement, it will take a time, a constant time, let's see. This will take c, initialization is only once in a for loop. The first initialization int I is equal to 0 is only once. If you remember the for loop, for int I is equal to 0, I less than n, I plus plus, this is only once. First it will initialize, then it will compare, do whatever it has to do, increment, compare, do, increment, compare, do. So it is executed only once, right? So it is, the second is c into n plus 1 times. It is a constant statement, but it executed n plus 1 times. Why it is n plus 1? Why not just n? Yeah, it is go on checking the value of, comparing the value of I with the size of the array. Every time it gets true, it is executed. In the last, when it gets false, also it is checked at the time of getting false. So n time it will get true, n plus 1 time it get false. N times it will get true, and n plus 1 times it will get false. After n it will get false. So here n plus 1. So 1 is for, what happened? N times for all the elements, plus 1 for 1 checking for false condition in the last. And this is n time, sorry, happened to this. This is c into n times, it is executed, and this is also executed, which is inside the loop at n times c into n, and this is c time. Now if you add all this, c plus c plus c plus c into n plus 1 plus cn plus cn plus c, okay, this is the first line, second, third, this is the fourth line, this is the fifth, sixth, seventh. So totally it is 3cn plus 5c. Okay. Now what is the time complexity in terms of big O notation? Big O of n, because these are constant values. Okay. So it depends on the value of n. So the time complexity here is big O of n. It is clear? This is how you are going to do in your exams. It should be clear to you so that you can do it easily in the exam. Is it clear? Or shall I repeat? Okay. Consider the following method that prints a pattern of stars. A pattern of stars. Now calculate the time complexity for this. Yeah, this is the second example you can take. Here you have two for loops. Now this statement is the static one, right? It will execute, let's say, constant time c. This is n plus 1, right? C into n plus 1. Okay. This is n into n plus 1. How come n into n plus 1? No, how it is n into n plus 1? This is n, right? N plus 1, sorry. Because it will execute n times, okay, plus 1 to check the false condition. 10 plus 1. When I becomes greater than n or equal to n, that is false condition, that is also checked. So it will check n times plus 1 false condition. This is n into n plus 1. How it is n plus 1? Okay, n plus 1 is again the same thing. It will check n time plus one false condition. But this n is for loop ish for the for أي loop هذا n اللوب الأول هذا برقم الأول صح. This n is from this loop. Now if you see in the inside the loop, any statement inside the loop is executed n times, right? So this loop is executed n times into its own n plus 1. Okay. So because it is an internal loop, the loop itself execute n times, but it is under another loop. That another loop make it execute n times. So it is n into n plus 1. This n comes from the outer loop and this n to its loop. Now this one is executed. No. C into this is the last statement is okay, it is C. N square times because this statement is inside the two loops. If it is inside only one loop, it execute n time. When it is two inside two loops, it will execute n square times, n into n times. Now add all this. This is n plus 1 plus n into n plus 1 plus n square plus n. So how much it is? It is again it will come n plus n square plus this is n square, this is n plus n square plus n, right? So it is 2n square plus 3n. So what is the big O? N square. Okay. So it means of the for loop will take that if there are two for loops, the big O will be n square. Okay. Now do not overgeneralize the result about the loops. Now you have seen in the first case it is one loop. No, it is yeah, it is something like go on working statement by statements, or you can say it is as debugging. Now if you see in this step the first loop, if it is one loop it takes big O of n. If it is two loops it takes big O of n square. Three loops will take three loops, then it will take big O of, say it is one loop, it will take big O of n. Two loops, big O of n square. Three loops, big O of n cube. Four loops, big O of n power 4. But this is not in all cases. We cannot generalize like this because the loop variation may be different in some cases. For example, over here in this example, this loop is executed how many times? N plus 1. This is n plus 1. How about this one? No, it is not n, it is m. M is different than n. So here it is n into m plus 1 and this is m into n and this is n. Now here which is the big O? Big O of mn or nm. So here there are two loops but it is not n square. Okay, so that's why it says do not overgeneralize the result about the loops. If it is two loops, both has n elements, both will execute n times, then it is n square. If it is three loops, all three loops will have n elements, n, then it is n cube. Okay, but two loops with different values, m and n, It is mn, not m square or n square. So it is big O of mn. This is the second. This is the first case. Let us take the second case. It is executed n plus 1. How about this one? N into this is 9n, this is n. Now what is the big O here? It's just n, because 9 is constant. Constant is removed. We will not take the constant. It's just big O of n. Okay. The inner loop here is a constant loop. Now consider this one. This one for I, this one is definitely execute n plus 1 times because it is n. How about the inner loop? The for I is equal to 1, it works one time only. For I is equal to 2, it works two times. For I is equal to n, it works n times. Okay, so it depends on the value of I. I will take from 1 to n. Okay, so it is n into n plus 1 divided by 2. N into n plus 1 divided by 2. So here the I value, as the I value increments, the repetition of inner loop is incremented. Okay, since the I will take the n from the outer loop, since I take n from the outer loop, we'll take for I the maximum as n. Maximum as n, so which is again belongs to big O of n square. So it can be, it is something like n into n plus 1, which is the maximum one. So if it is n into n plus 1, then it is definitely n square. So in these cases is also belongs to big O of n square. In this two loops, I'll repeat, in this two loop, the first will take n plus 1 time. The second will take, it depends on the value of I. Initially for I1, it will work only one time. For I2, it will work two times. It goes on till the value of I. If the I reaches to n, it will work n times. Okay, so here that is also comes under n square. Now you suggest what is the time complexity for this? Tell me the complexity. For the first, how come? How come? It is correct, but how? N cube. After a square, it is cube. 10 power 3. First, it is n plus 1, right? The second is n into n plus 1, that is n square. The third is, that is the third inner loop, n into n plus 1. So what is n into n into n? N cube. So it is big of n cube. What about this one? No, it is counted as n cube. It is counted as n cube. So we consider this or this. What about this one? See, these are all constant. This is n square. Okay. This is also n square, and this is also n square. Okay. But you see, there is a changes in the I and j over here. Of course, there are increments over here, but there are also changes in the I and j over here. Okay. So due to these changes, it is log n, because the I is okay. It is n into n plus 1. I is incremented, just incremented, but j here is multiplied again. Okay, so I will take n, whereas j, since it is multiplied, it will take log n. So it is big of n log n. For this is constant, n square. This is constant, so constant is not considered. Two loops, two loop is n square. Correct? How about this? Big of n plus m or maximum of nm. Either the addition of these two or no, maximum of these two. Because we take the maximum one, the worst case as I told. So maximum one, if any one n is more than m, greater than m, then we will take the m complexity. Sorry, n complexity, because it is the maximum time. In this time, m will also execute. If both are equal, then we add both as one. For this code, big of n. For this code, big of n. For this, mn. Sorry, equal for, yeah. 6 has a, see, this is m, this is n, this is m. N is different, m is different. We cannot say, if both are n, we say n square. Why? Because we multiply n into n square. But if m is different, two are different, then we are going to multiply it, nm. So it is big of nm. Okay, n for this and m for this. Example of, here this is a different for loop and this is a different for loop. This is different, this is different. هذا loop لحاله وهذا loop لحاله. This is inner loop. This case is inner loop. So now we understand again the best, worst, and the average case why having this problem of searching an element. Now the best case is when the program first found at the first position, or the element found at the first position, it is the best case. In the case of best case, it will execute only one time, so big O of 1. Big O of 1, because it is the best case found at the first position, big O of 1. In the case of worst case, it will go all the elements, n elements, then the time complexity of big O of n. In the case of average, it is probability of event occurring into event times if the event occurs. So that is, it can be big O of, it belongs to big O of n. Big O of n. So these are three different cases. We consider the problem of searching an array to define these three cases. It's clear? Now here the best, worst and the average case. Best case is always less than the average, which is always less than the worst case. Because best case can comes to big of 1, worst big of n, but average it belongs to big of n. We cannot say exactly big of n. It can be plus or minus. So it is belong to big of n. Okay. So this is what we have in algorithm analysis. In this chapter, from this chapter, what you get is analyzing the codes. Analyzing the code and writing these in every step. Right? What is the constant c, which will take n, which will take n plus 1. Finally, what is the complexity using big O? Big O of n or n square or n into m or n log n. So when it comes log n, see, if there is a single statement which execute only once, it is constant c. The big O, the notation for this big O is big O of 1, executed only once. If it is a one for loop which execute n times, then big O of n. If it is two for loops executing n into n times, both n, outer for loop, inner for loop, both are n, then it is big O of n square. If it is two for loop, one executing n times, the other executing m times, then it is big O of mn or nm. Okay. If it is, for example, let's say if it is three for loops executing n into n times, then it is big O of n cube. If there is a constant, for example, two for loops having one n, the other as constant, 5, 6, 10, 12, whatever, then this big O of n. If it is, let's say for example, if it is one for loop having n times, but the increment of I is changed by dividing or by multiplying. By dividing, so it is log n. If it is one for loop, if it is two for loop, one with a n, the other with a log n, that is the other loop has some division or multiplication, then it is n log n. Okay, n log n. Two for loop, one execute n times, the second execute n times, but its increment or decrement is disturbed by dividing or by multiplying, then it is n log n, big law of n into log n log n. So like this it goes. Okay, and you need to read the code. You see which is the constants, what are will take n, which will take m if there is any m. If there is any division or multiplication in the variable of incrementing, decrementing, then that will take log n. Okay, so if there is a log n, you need to multiply that log n with another n if there is any other n. Okay, and you need to understand what is the best, worst and the average case. Three cases for the algorithm. Okay, this is the overall summary of this unit. So if you have any questions regarding to this unit, you have your midterm exam in the coming days. When it is? When is the midterm exam? 21st. 21st? And what are the units will be covered up to here? Until algorithm analysis. Until this presentation or this meeting uh, is included for your midterm exam. Okay. So what you have from the beginning, you have arrays, 2D array, text processing, linked list, and algorithm analysis. Arrays, 2D arrays, text processing, linked list, and algorithm analysis. So you'll be having some problem from the linked list, from the algorithm analysis, and might be from the arrays. It's all easy, it's not so difficult. Arrays, you have studied arrays before. Text processing is two-dimensional arrays will come. Okay. So two-dimensional array, you have to use two for loops. That's it. That's the difference between one dimension, two dimension. That's it. Text processing, you have studied. You have to use those methods: char add, sub index, these methods, index add, these methods. So after that, linked list. That is, you need to remember about the linked list, how the linked list is processed. Doubly linked list, circular linked list. And then you have this one. So thank you very much. We'll see inshallah if there is any lecture. If there is a lecture before your exam, in that lecture we are going to discuss it. When is our next lecture? There is no lecture, right? Lecture will be after the exam. I'll see inshallah. 18 or 19? 18. Yeah, just a revision, I think. يوم السبت 19 اختبار يوم السبت يوم الخميس اوكي خلاص ان شاء الله عايز يوم تسعة. بس ارسل لي ايميل ها ارسل لي ايميل ان شاء الله will try and كم التاريخ يوم الخميس 19 okay 19 ان شاء الله we'll have a meeting. Okay, revision of the midterm exam, previous midterm. There are 4 previous midterm exams. Sorry? Yeah, it is online definitely. Okay, and the other thing is there are some video lectures recorded by some doctor from Lebanon, and it is available to you. You check your emails. Coordinator has sent some video links for you on the YouTube. If you prefer to, you just can check. Okay. Time for the next lecture, we will keep it at 4:30, 4:30, 4:30 for the discussion on 19. Arba ونص. Okay. Okay, then see you inshallah in the next meeting. Thank you very much. Yeah. Yeah, we are in the midterm up to you. Oh, Allah Africa.